In this question, we're told that OABC is a trapezium. We're given the vector OA, which is equal to A, the vector AB, which is equal to B, and the vector OC, which is equal to 3B. We know that D is a point on OB, such that the ratio OD to DB is equal to 2 to 3, and E is a point on BC, such that the ratio BE to EC is equal to 1 to 4. We need to find the vector DE in terms of A and B, giving our answer in its simplest form. Now we have quite a complicated looking diagram over here, and so we can separate these into a bunch of different triangles, which will help us to find the vector DE in terms of A and B. Let's start with our triangle OAB. We know that the vector OA is equal to A, and the vector AB is equal to B. We can start by finding the vector OB. And now we know that to get from O to B, we can go from O to A, and then A to B. And so the vector OB would be equal to vector OA plus the vector AB, which in this case would be equal to A plus B. But now we're told that D is a point on OB, such that the ratio OD to DB is equal to 2 to 3. Now this has a total of 5 parts, and so the length OD has 2 of these 5 parts, and the length DB has 3 of these 5 parts. So we can therefore say that the vector OD is 2 out of 5 of the vector OB, and the vector DB is 3 out of 5 of the vector OB. Now let's move on to our next triangle, triangle OBC. We want to find the vector BC, and to find the vector BC, we can go from B to O, and then O to C. Now we know the vector OB because we found in our first triangle that the vector OB is equal to A plus B. And so the vector BO is the same vector but in the opposite direction, and so BO would be the negative of OB. If we know that OB is equal to A plus B, the vector BO would be minus brackets A plus B. We also know the vector OC because we're told in our question that the vector OC is equal to 3B. And so BO plus OC is equal to minus brackets A plus B plus 3B, and simplifying, minus brackets A plus B becomes minus A minus B, add the 3B, and we're left with minus A plus 2B. And so we found that the vector BC is minus A plus 2B. But now we're told that E is a point on BC, such that the ratio BE to EC is 1 to 4. And just like before, we have 5 parts. BE has 1 of these 5 parts, and EC has 4 of these 5 parts. And so we can say that the vector BE is 1 out of 5 of the vector BC, and we can say that the vector EC is 4 out of 5 of the vector BC. And so we're now left with our final triangle, where we can find the vector DE, which is what the question is asking us to find. Using this triangle, we can see that the vector DE is equivalent to the vector DB plus the vector BE. Now we said that the vector DB is 3/5 of the vector OB, and we said that the vector BE is 1/5 of the vector BC. Let's start with the vector DB. DB is 3/5 of the vector OB, which we found in our first triangle. OB is equal to A plus B, and so DB is 3/5 multiplied by A plus B, which will leave us with 3 out of 5A plus 3 out of 5B. Now we can do the same thing for BE. We said that the vector BE is 1/5 of the vector BC, and we know that BC is equal to minus A plus 2B, and so 1/5 multiplied by minus A plus 2B will leave us with the vector BE, which is equal to minus 1 over 5A plus 2 out of 5B. Now we know that DE is equal to DB plus BE, and so we'd do 3 out of 5A plus 3 out of 5B plus minus 1 out of 5A plus 2 out of 5B. And so when we simplify this, we'll end up with the vector DE, which is equal to 2 out of 5A plus B. Now this question is worth 4 marks. We get the first mark for finding the vector OB, and for also finding that OD is 2/5 of OB, and DB is 3/5 of OB. We get the second mark for finding the vector BC, and for also finding that BE is 1/5 of BC, and the vector EC is 4/5 of BC. We get the third mark for using these ratios in order to find that the vector DE is DB plus BE. And we get the fourth and final mark for correctly simplifying and getting a correct answer that the vector DE is equal to 2 out of 5A plus B, allowing us to get the full 4 marks needed in this question.